Hello everyone, there's been some maths in the news this week with these headlines. Wikipedia-sized proof too big for humans to check. So, a Wikipedia-sized proof, hopefully more accurate than Wikipedia, but what did they do? Now, I'm going to explain to you what they proved this week, and I'm going to do this through a puzzle. And it's going to be a puzzle that we can all play, we can all solve at home, and you won't need a Wikipedia-sized proof to do it. So, let's start. So here's my puzzle. Alright, so there you are. Behind you, 2 steps behind you is a cliff. 2 steps in front of you is a nest of angry snakes. And not just any old angry snakes, but like snakes with really bad breath and stuff. So, your torturer tells you that you can go free if you can write a set of 12 instructions that you have to follow without falling off the cliff or being poisoned by the snakes. A move is either 1 step forwards or 1 step back. But your torturer warns you that he might decide to make you follow every second instruction. Instruction 2, 4, 6, 8, 10, 12. He might make you follow every 3rd instruction, or every 4th instruction, or every 5th instruction, or every 6th instruction. Bop. Can you write a set of instructions that will keep you safe? Now, if you want to try this puzzle, do it now. Pause the video or something, because I am going to talk about the solution after this flash. So hopefully you're ready for the solution now, because this problem is actually one of those impossible problems. So give it to someone you don't like. Now, how can we prove that this is impossible? Let's try that out. So we've got 12 instructions to fill in. Okay, so 1 to 12. So let's start off with, let's say we start off with 1 step forwards, because why not? So we're going to start with 1 step forwards. Now, our next step is going to have to be a step back. We can't have 2 steps forwards because we'll end up in the nest of snakes. So our next step has to be a step back, which I put in there with a -1. Now, don't forget, our torturer can make us follow every 2nd instruction. If he does that, then you'll start with instruction 2, then it's instruction 4 next. So instruction 4 cannot be a step back, because you'll have 2 step backs falling off the cliff. Instruction 4, you're forced to find out that it's a 1, you're stepping forwards 1 place. So I can write that in like that. But we can do the same again with the 8th instruction. If the torturer makes you follow every 4th instruction, then you don't want to go forwards twice. So number 8 is actually a step backwards this time. So we can fill in all those instructions. Those all come for free. Now let's fill in some of these gaps. Let's fill in the gap there in the 3rd place. Well, let's see what we got here. Step forwards, step back. It can't be 2 steps forwards next. So this one, number 3, has to be a step back. So I'll fill that in. So we've got -1 there. Now again, you could follow every 3rd instruction, which forces you to deduce that the 6th step must be a step forwards. It must be a +1. I'll write it in. So we got +1 there for the 6th step. And then by the same logic, if you follow every 6th instruction, you can't make 2 steps forward. So number 12 is a step back. It's a -1. And I'm going to write that in as well. There we go. -1. Now what else can I fill in? I can fill in this gap here with the 5. Step forwards, step back. That's okay. Step back, step forwards. We can't have 2 step forwards here, not in a row. So number 5 has to be a step back. Number 5 is a step back, and then automatically you get number 10. Number 10 will be a step forwards. So that will be with a +1. Let's see if we can fill in these remaining gaps. I think, let's see, step forward, step back, step forwards, step back, step forwards, looks fine to me. We can't have 2 step backs here. This must be a +1. Let's fill this in, and in the same way, number 9 here is a -1, and number 11 is a +1. So you fill in these instructions. Now all of this was forced on me, there was no free choice here, but if you look at every third instruction, so 3, 6, 9 and 12, you go step back, step forwards, good. Step back again, whoops-a-daisy, fall off a cliff. So you're forced to fall off a cliff. These were the only instructions that you can really come up with, and still you will die. So you'll find out that it's an impossible problem. But this is quite nice. If I remove the last step there, number 12, so we just have the first 11 steps, then those instructions do work. Those 11 instructions will keep you safe. So if you want to give this puzzle to someone you like, ask them to give 11 moves instead of 12. So that's what happens when the cliff and the snakes are 2 steps away from you. So what would happen if the cliff and the snakes were 3 steps away from you? How many instructions would your torturer force you to write so that he can guarantee that you'll die? So this was an open problem, but it was solved this week by these 2 guys from the University of Liverpool, and they worked out that the solution is 1161. So if your torturer makes you write 1161 instructions, then he's guaranteed to have at least one subsequence that will topple you over the cliff with 3 steps. Now that does also mean that there is a sequence of 1160 that will keep you safe. And here's one of them. So to prove this result, it took them 6 hours using computers. They didn't say how many computers they used, but they generated a 13 gigabyte file, which they compared to Wikipedia, because apparently the text for Wikipedia is a 10 gigabyte file, and they claimed it was the longest proof ever. It's an example of a computer-assisted proof. It looks like a clever kind of brute force. I tried to read the paper, but I'm not a computer scientist myself, so I didn't quite get it. So if you want to read the paper, I'll put the link in the description. Now what we've shown is, if we have the cliff 2 steps away, we can kill the guy. If we put the cliff 3 steps away, we can kill the guy, if we have a long enough sequence. So is this always true? Is this true for any number? This is called Erdos Discrepancy Problem. It was proposed by the Hungarian mathematician Paul Erdos in the 1930s. These guys from the University of Liverpool are already working on the next step. So imagine the cliff now 4 steps away. They're trying to work out how many instructions you need to guarantee that you can kill this guy. But we're going to need a smarter way to solve it in general. We can't just check every number in turn. So why do this? Well, I could talk about discrepancy theory and wireless communication and cryptography and applications like that, but the real reason we do it is because it's a hard problem, and the methods we develop to solve this problem could then be used in other problems, perhaps more important problems. It adds to our knowledge of the world. Now, they are working on the next step. Imagine the cliff 4 steps away from you. They haven't yet found what length sequence you need to guarantee to kill your victim, but they have found a sequence of 13,700 that will keep you safe. So any subsequence will never be longer than 4. So you can avoid the cliff and you can avoid the snakes. I'm going to show you what that sequence looks like. It's going to scroll past. It's going to take about a minute. So for now, if you have been, thanks for watching.